Ladies and gentlemen, prepare to get mathematical. Slope-intercept form is the most commonly used form of a linear equation, or likely. Probably because of its popularity with statistics, but you would probably learn that a little bit later. So today we're going to go over what slope-intercept form is, and the goal is for you to be able to take an equation in slope-intercept form, identify the slope and the y-intercept, take a slope and a y-intercept and put it into an equation, and also take an equation, turn that into a graph. And I think we're also doing graph to equation. So we're going to go all directions, all different ways. So first off, let's kind of take a real quick refresher for slope and y-intercept and what those things are. Maybe you're not sure. That's okay. All right. So the slope is just a number that describes how slanted a line is. So if you have a line like this, when you see that, I have a rough idea of what the slope is, even assuming that we know the scales on the x and y axis are the same. You can kind of get a rough idea what the slope of this line is going to be. Okay, and the reason, or the way that I would do that is, I know that a horizontal line has slope m equals 0. Also, I know this slope is positive as I go from left to right, it's slanting up. And then a line that is at like a 45-degree angle when the scales are the same has a slope that is 1. So this line is kind of between, I guess it's this way on the camera, this line is kind of between 0 and 1. So 1's right there, so it's somewhere in the middle. So that means the slope is somewhere between 0 and 1. So a good guess here might be maybe like the slope is like 1/2 or something. So big thing here is slope describes how the line is slanted. If it's really steep, it's bigger than 1. And if it's going downhill as you go from left to right, that would be a negative slope. Okay, and the y-intercept is really straightforward. The y-intercept is just the point. I figured out why this was so laggy too last time. Sorry about that. The y-intercept is just the point at which a line crosses the y-axis. So that would be this point right here. It is the point where the line, or a line, crosses the y-axis. So the way that I remember this word intercept is like football interception. You have the path of the ball crossing the path of the defenseman, and they pick it off, right? So that's where these things cross, the y-intercept, where the line intercepts the y-axis. Fantastic. So what is the form of the slope-intercept equation? The form is as follows. Flub that. Here we go. All right, so you have here the slope is represented by the letter m. So slope-intercept form, you can tell something's in slope-intercept form if it says y equals. If it starts with y equals and it's a linear equation, it's in slope-intercept form. So this is our slope. It is always the coefficient of the x term. It's the coefficient of the x term. That's the slope. And we represent the y-intercept with the letter b. And I already told you what the y-intercept is. Okay, so we represent the y-intercept by the letter b. But why? I don't know. Couldn't tell you. I think it's just random. And sometimes they're represented by different letters in different fields, but for the course of Algebra 1, we'll be using m and b. It is important to note that this equation, y equals b plus mx, you can also in a way, call this slope-intercept form. It's kind of intercept-slope form, but you can still look at this equation and find the slope quickly and the y-intercept quickly. And the reason this form of the line is so popular is because when you are describing the relationship between two variables in the real world, like maybe it's a total cost of a project and time spent on a project, or maybe it's the number of COVID cases in your area over time, whatever. Okay, you have two variables and you're comparing them. Turns out the slope and the y-intercept kind of have real physical meaning, and you'll learn that more in the statistics section. But this is a very important equation, especially for making predictions with linear data. Okay, so let's go ahead and work through. So I guess what I'm trying to say here before I move on is these two equations are basically the same. They're both in slope-intercept form in a way, and you can still use them. The bottom one is just as useful as the top one, as long as you know how to identify. And the b, the y-intercept, is always going to be that constant term. Okay, moved on a little too fast. That's okay. All right, so let's go ahead and tackle this first one. I'm going to go through the steps. Okay, your first step when graphing an equation in slope-intercept form, is it in slope-intercept? Yep, it says y equals. The first thing you want to do is you want to identify m and b. Hey, that's one of our goals. So you're going to look at the equation and you are going to identify the slope and the y-intercept. I said the slope is always the number that is the coefficient of the x term. The coefficient of our x term is negative 2/3. Hooray! That's our slope. And our y-intercept is always the constant, which is positive 3. Fantastic. Hey, that's step 1 complete. Cha-ching! Step 2. Let's see. So step 2 is I would say, actually this is kind of important. Right, we'll do that later. Let's do plot the y-intercept. Kind of tweaking it a little bit to how I taught it in class today. Plot the y-intercept. Okay, so that's real easy. We figure out, it says b equals 3, so that means that our line crosses the y-axis at 3. Now this is great. The y-intercept gives us a starting spot. We know our line passes through that point, so what we can do is then use the slope and start at that point to create a pattern across our graph. Okay, so 3 is use the slope in fractional form to plot more points. I'll just say more points. There are an infinite number of points on the line. We're just plotting some of them. In fact, we're only plotting the ones that land right on the grid line intersections. You can plot other ones as well. Okay, super. So let's take a look-see at how we're going to do that. I said write our slope in fractional form. It's already in fractional form, we're good. Sometimes it's not. Sometimes it's just like m equals 9 or something. So it's already in a fractional form, so we're good. And remember, slope is equal to rise over run. So the way that I teach finding these other points is first think about, is this slope going to be positive or negative? Well, it's negative, so that means it's got to be slanting downhill. Okay, now we know it's got to be downhill. I look at the rise. The rise is 2, so I can go up or down 2 in the vertical direction. It doesn't make a difference because the line is going like this. We'll be able to find a point. So if let's say I go up 2, if I want my line to be negative, I know I'm going to have to go in the x direction 3. But if I want my line to be negative, I have to go to the left. If I go to the right, it'll be slanting uphill. So I'm going to go up 2 and to the left 3, and I pulled those numbers from right here, and I know it's got to be negative. Great, fantastic. Had I gone down right here, if you go down 2, then in order to keep the line sloping down negative, you would need to go over to the right 3. And now we can repeat that pattern all the way across our graph and get a nice, beautiful line that we can write to our grandmothers about. Dear Grandmama, today in algebra class I wrote the most stupendous line with my teacher. I think I'll bring him coffee in the morning and also some sweet cakes of yours that are your favorite. Okay, I've taken that too far. There we go. There's our line in all of its glory. Ooh, it's so, ooh, ah, ooh. Okay, so again, ID M and B, plot the y-intercept, use that as the starting point, make sure you have your slope as a fraction, and use that as a pattern to put the rest of the points. Let's do some more examples. I'm not going to write the steps this time. Switch into red. Okay. We got to identify the slope and the y-intercept. Okay. The slope is always the coefficient of the x-term. Careful. Oh, I saw you were going to say 8 was the slope because, or negative 8 was the slope because that came first over here. You got to make sure that it's the coefficient of the x-term. So 4, let's go ahead and let's think ahead. Let's write that as a fraction right now. As a fraction, that is 4 over 1. And b is negative 8. Great. Okay. Step 1 complete. Cha-ching. Y-intercept, negative 8. We go down. The line has to cross down here. Okay, Sherlock Holmes. We've got a clue. Okay, we're starting here, and we need to put the line going. We need to put the rest of the points on the line. Thank you. Now, notice I can't go down 4 here, but I can go up 4, so that's fine. So if I'm going up 4, the slope is rise over run, remember? If I go up 4, if my rise is 4 and my slope is positive, to keep my line positive, as in slanting up like this, I need to go 1 to the right. So we're going to go 1 to the right this way, 1 to the right that way, and we're going to keep that pattern going up 4 over 1 all the way across our graph. I'm going to come back, draw that through our points. Of course, you are using a straight edge here for drawing that line to make sure it's nice and pretty on your assignment. Okay, beautiful, amazing. One little comment about what does it mean? What is this equation? The equation describes the points on the line. That's what it does. Okay, it's giving us basically a rule that tells us where all the points on the line are. How exciting is that? Now, if we take the coordinates like 4, 8, now let's not do that one. Let's do a different one. I don't like that one. Let me take this coordinate right here, or even this point right here. It looks like 3.5, 6. Ooh, that's exciting. Let's do the point 3, 4. If you take the point 3, 4 and we plug in x and y into the equation here, what that's going to do is that is going to, if we get a true statement, it means this point's on the line. If we get a false statement, it means it's not. So we can check. I mean, we know it's on the line because we just graphed it, right? But let's go ahead and try it out. I'm going to plug this in. We're asking the question, I plugged in 4 for y, is 4 equal to negative 8 plus 4 times 3? Is 4 equal to negative 8 plus 12? Cha-ching! That's true. Okay, and if you pick a point off the line, like, I don't know, 1, 2, that one should be false, right? So we can check 1, 2. This is checking 3, 4. If you check 1, 2, plug that maybe in, you get 2 equals, is that equal to negative 8 plus 4 times 1? No, that's not. 2 is not equal to negative 4. Okay, not on the line. Cool. That's going to come into play later. All right, let's take a look at the next one. Y equals 5 over 4 x. Ooh, ooh. Step 1, identify slope and y-intercept. You guys are, this is boring. I got this down. I got it down. This is not a problem. The slope is the coefficient of the x term. There's my x term. Easy peasy. 5 over 4. Some people want to tack the x on. Be careful. You don't tack the x on. The other common mistake I get is instead of using, when the slope is written as a number like this, instead of using the fraction for rise and run, people use these two things. You don't do that. Make sure you're just using the slope for rise and run. All right, so here we go. And B is our y-intercept. Where does it cross the y-axis? Well, there's no number written. If there's no number written, that means we can write a 0. So our y-intercept is 0 because 5x plus 0 is still 5x. Isn't that exciting? Okay, great. Now, or 5/4 x plus 0 is still 5/4 x. So this gives us our starting point. So we plot it right here. And once you get the hang of this, guys, it goes really fast. And the rise over the run is 5 over 4. Now notice if you go down, let's go down 5. If I go down 5 in the vertical direction, I know my slope is positive. So to keep it positive, as in slanting like that, I'm going to go down 5 and over 4. And up 5 and over 4 this way. And we can keep those in line. Super. All the way across our graph. Isn't this fun? I just cannot think of a better way to spend an evening than graphing lines. Beautiful. Straight lines for good times, folks. That's what my mom always used to say. All right. I'm happy with that. Let's keep cruising. Beware of lines written in green ink. You try this one. I bet you can do it. You can do it. I bet you can do it. You got it. You know what? Yeah, let's do this. M equals. B equals. B is easy. It's the constant. Get out of here. What's the slope? There's no number written there, Mr. Slagle. The slope is 0. Just kidding. We don't write it because it'd be boring to write it every single time. And hassle. How many x's do we have? 1. The coefficient there is 1. We don't write it. That's the rule. Okay, this one's a little funkier because step 2 says plot the y-intercept. Okay, we're up at 3. Done, check, over, kaput. Step 3, write your slope as a fraction. How do you write run as a fraction? Well, there's many ways you can write 1 as a fraction. You can write it as 1 over 1. You can write it as 2 over 2. You can write it as whatever you want. So if you're going to do that, you're going to start here. You just, basically what this is saying is every time I go up 1, I could write it as 8 over 8. That's still equal to 1, right? So I could go up 8. Oh, I can't. There's not enough room on the graph. It'd be up here at 11, but that's okay. Well, you get the point. Your rise is the same as your run. So when I go up 1, to keep my line positive, I'm going to go over 1. If I go up 2, I'm going to go over 2. And you'll notice if I continue that, all these points will be on the line. I can go down 8. Let's go down 3 and then 5 and go over 8. This point is also on our line. Pretty exciting. And if you trace it back, let's do like up 3 over 3. All those points are in a perfect line. Lots of fun. Lots of fun. Great. Let's see here. Let's graph our line and make sure it goes all the way across our graph. Nice and pretty. I'm going to try that one more time. That was not nice and pretty. I'm not getting any sweet cakes. Okay, there we go. Perfect. Isn't that it's so beautiful? Math is fun. Let's keep moving. All right, sometimes you're given a graph like this. What's the strat? What is the strat? How do we write an equation? Well, all you need to do is find m and b, folks. Let's find them. B is the easiest. Where does it cross? -3. M is also not too bad. If you can find another point that it travels through, looks like it goes through that one. Now you just count over and down. What's my rise? 3. What's my run? 5. It's going downhill, so my slope must be negative. Rise 3 over 5. Done. As an equation, remember I'm subbing this into y equals mx plus b. So you can't, this would be y equals negative 3 over 5x. Now we could say plus negative 3, but that can be simplified to just minus 3. Fun, fun, fantastically fun. Next one. You guys try this one on your own. Pause it. No cheating. Y-intercept. 2. Slope. Up 1 over 5. Okay. M equals rise is 1, run is 5. B is equal to 2. Y equals mx plus b, plugging in for m, plugging in for b, y equals 1/5 x plus 2. Fun times. All right, smarty britches. You know, this is easy. Handle this one if you possibly can. M equals this, b equals this. It's completely horizontal. Hey, let's jump in the way back machine at the beginning of the lesson. Remember when I said, hey, remember what a horizontal line slope is? It's 0. So this has slope 0, and it has y-intercept 3. So if we're plugging in to y equals mx plus b, this will be y equals 0x plus 3. What operation is between 0 and x? Times, and 0 times anything. If you have anything 0 times, how much do you have? 0 plus 3, which is just y equals 3. And what this equation is it describes all the points with the y value 3. This is 0, 3. This is 4, 3. This is 9.5, 3. Fun stuff. Lots of fun. Don't need to do that one. We did a Jamboard in class, but that's about all I got for you, folks. Your assignment is in Google Classroom. Thank you for watching, and I hope that this was helpful for translating between equations and graphs. We got mathematical. I think you could say we got mathematical today.